Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Nafahani binti Ali. I'm going to present my final year project entitled Analysis of Total Harmonic Distortion for H-Bridge Inverter in DC Motor Application. My supervisor is Miss Siti Azura binti Ahmad Tarusan, and my panelists are Madam Atikah binti Razi and Associate Prof. Dr. Kasro bin Abdul Karim. This is the agenda of the presentation, which are project overview, objective, project scope, methodology, result and discussion, conclusion, and future work. First, I will explain about project overview. DC motor represented by using receptive inductive load, which is RL load, may produce a harmonic distortion problem. The harmonic can cause an energy loss and increase in heat that may deteriorate the insulation as well as decrease the efficiency of motor. Due to this, we will issue the high total harmonic distortion if the improper switching is used. The RL load will perform the square waveform and sinusoidal waveform in bipolar and unipolar switching. Apart from that, the performance of the inverters depend on the control strategy adopted to generate the gate path. Therefore, the current control method I use to control the inverter. The modeling of proposed hysteresis current controller for H-bridge inverter to improve the total harmonic distortion by using hysteresis current controlling method are implemented. The proposed HCC is capable for lowering the THD and to provide constant switching frequency. The step development of the analysis of total harmonic distortion for H-bridge inverter will be discussed. It focuses on the PWM definition and consideration in terms of frequency modulation index and amplitude modulation index. Next, I will move on to project objective. First, to study the principal operation of H-bridge inverter for DC motor application. Second, to design and simulate the H-bridge inverter circuit by using unipolar and bipolar switching in MATLAB Simulink. Third is to design and simulate the H-bridge inverter circuit by using hysteresis current controller in MATLAB Simulink. And the last is to analyze and compare the total harmonic distortion performance of H-bridge inverter circuit. Next, I will move on to project scope. There are several scopes of my project, which is simulation on H-bridge inverter using simulation toolbox in MATLAB is used for controller and algorithm. Second is proposed circuit and HCC technique using square waveform and sinusoidal waveform by bipolar and unipolar switching, and proposed hysteresis current controller inverter. Third is analyze data using FFT analyzer to counter performance of THD for H-bridge inverter in DC motor application, and performance of total harmonic distortion in variation of frequency and amplitude modulation index. For the methodology part, I divided with three phases, which is phase 1 is flowchart of the project, phase 2 is modeling of the inverter and hysteresis current controller, and phase 3 is analyze the THD of the improvement modeling, inverter and hysteresis current controller. For the first methodology is project flowchart. This flowchart will present all procedure of workflow during FYP season. After completing all the procedure, I will complete the FYP report. Then for the second methodology is modeling circuit for inverter. I divided with two parts, which is modeling of inverter for switching and modeling H-bridge inverter with proposed HCC. The first part is design the square waveform in the Simulink. In square waveform, the pulse generator will use, so this is the parameter that used to set up the parameter in this square waveform circuit. Next, modeling circuit of sinusoidal waveform, which are bipolar and unipolar switching in the Simulink. In sinusoidal waveform, the sine wave will use, so the parameter that set up the circuit is same with the square waveform. For the unipolar switching, the parameter that used is same with bipolar switching. Next, modeling of the sinusoidal path with modulated inverter with no controller with sinusoidal reference are implemented. Then, move on to the hysteresis current controller circuit modeling, with the methodology is based on current injection to the gate drive circuit. The proposed HCC block has four proposed, which is proposed 1, proposed 2, proposed 3, and proposed 4. Next, for the last methodology is development of analysis of total harmonic distortion, with divided with two parts, which is frequency and amplitude modulation index, and analysis of proposed HCC. First part is using PWM definition and consideration in varies in frequency and amplitude modulation index. Second part is the effect of the frequency modulation index to HCC proposed when using the simulation of 10 variation of the value of MF. And the effect of the amplitude modulation index by using seed variation of the value MA. Next, we move on to the result and discussion. Have 4 parts, which are performance of THD in inverter for switching. Second, analysis of effect THD varies in MA and MF for switching. And third is performance of THD and SPWN inverter and proposed HCC. And the last is analysis of effect THD varies in MA and MF for proposed hysteresis current controller. For the result and discussion, section 1 is performance of THD in inverter for switching. First, move on to the square waveform. In terms of THD current, square waveform produced 32.61% and for THD voltage is 48.03%, while the switching waveform is 43.34%. In sinusoidal waveform, for bipolar switching, the THD current produced is less than square waveform, which is 14.31%. And for THD voltage and THD switching waveform is 103.84% and 104.07%. Then, for the unipolar switching, the total harmonic distortion produced better THD level of current, which is 8.31%, and THD voltage is 56.79%, and the THD of switching waveform is 104.07%. For the comparison of the square waveform and sinusoidal waveform with analysis of THD level from the data by using unipolar switching, the performance of THD current is better, which is 8.31% compared to the square waveform and sinusoidal bipolar switching. Then, for the performance of THD voltage and output with switching, by using square waveform, we produce low THD compared to the sinusoidal waveform, which is 48.03% and 48.34%. For the second section of result and discussion is analysis of the effect of THD varies in MA and MF for switching. In square waveform, the summary of THD in terms of frequency and amplitude modulation index. If MA less than 1, the amplitude of the fundamental frequency of the output voltage is linearly proportional to MA. Alternatively, MA can be varied to change the amplitude of the output. If MA more than 1, the amplitude of the output increases with MA but not linearly. Next, for the bipolar and unipolar switching, by using variation of frequency modulation index, the unipolar switching have better THD result compared to the bipolar switching, but both have the same value of THD performance in switching waveform. By increasing MF, increasing carrier frequency, increase the frequency at which the harmonic occur. Next, in terms of varies in amplitude modulation index, from the data, by using unipolar switching, we produce less THD performance compared to bipolar switching. So, if MA less than 1, the THD will higher, and if MA more than 1, the amplitude of the output increase with MA but not linearly. Besides that, by using the same MA to the bipolar and unipolar switching, the THD switching for the both switching is same. Next, for the third section of result and discussion is divided with 2 parts, which is performance of THD in SPWN inverter and second, performance of THD in proposed HCC. First, the analysis of THD of SPWN inverter without controller by using the parameter MF equal to 20 and MA equal to 1. The total harmonic distortion was observed, which is 42.67%. Next, we move on to the THD in proposed HCC block by using MF equal to 20 and MA equal to 1. For proposed block 1, the THD is 10.49% and for proposed block 2 is 26.41%. And continue for the proposed 3, the THD is 16.67% and for proposed 4 is 16.86%. So, this is the graph that shows the overall of the summary of this section, which is for proposed HCC have better total harmonic distortion value compared to the without hysteresis current controller. Since the proposed HCC block 1 have better performance of THD result, which is 10.49%, it may be used for the getting signal control in the H-bridge inverters. Lastly, for the result and discussion section 4 is the analysis of the effect THD varies in MA and MF for proposed HCC. First, in terms of the effect of frequency modulation index of THD when varies in MF, based on the graph and table when using the same MA and the greater the value of MF, then the value of THD tends to decrease. In this analysis, THD current in proposed HCC Block 1 give the better THD, which is 5.78% when the frequency modulation index is 70. Second, the effect of amplitude modulation index when the test carried by using variation of MA with the parameter of MF that gave the better value THD current in previous discussion. Based on the graph and table, THD performance in proposed HCC block give lower THD current compared to the previous analysis. So, whereas frequency and amplitude modulation index greatly affect the value level of THD current to the proposed HCC inverter. Therefore, for the summary of the total harmonic distortion, based on the graph and table, when using the improvement of proposed HCC with PWM definition and consideration, the improvement of proposed HCC circuit have better in producing less THD in terms of current that will be used for the gating signal control in H-bridge inverter. Since the proposed HCC block 1 producing less THD, which is 5.78% compared to before improvement, which is 10.49%, it may cause less energy loss, reducing heat, lead to deterioration of insulation, and increase the motor efficiency. So, proceed to the last section is conclusion and future work. So, in this project, I can conclude that by analyzing the THD performance of H-bridge inverter in DC motor application, the principal operation of H-bridge inverter for DC motor application has been clearly overviewed. The implementation of H-bridge inverter circuit by using bipolar and unipolar switching is carried out and simulations results are presented. The analysis of performance evaluation results show that the THD for unipolar switching have better THD level, which is 8.31% compared to the bipolar switching is 14.01%. The implementation of H-bridge inverter circuit by using proposed hysteresis current controller method was applied. Besides that, it has improved and have better reducing THD level compared to the SPWM inverter without controller. Since the proposed HCC block 1 have better THD distortion level, it may be used for the gating signal control in H-bridge inverter for DC motor application to control the inverter. And future work, as for this progress in the future, we will be completely implementing the simulation for computational mapping circuit design and mathematical conclusion in the harmonic component ejection. By using fuzzy controller applies an intelligent control that have fast processing implementation algorithm. So that's all from me. Have a nice day. Thank you.